Measures of position gives us a way to see where a certain data value falls in a sample or distribution. A measure can tell us whether a value is about the average or whether it's unusually high or low. In short, it divides the group into lower and upper group. Quantiles are common tools in measures of position. In this video, we are going to solve quartiles using linear interpolation. Suppose this is a data set, and of course it is 100%. Quartile divides the distribution into 4 equal parts. Each part is equal to 25%. This position is called the quartile 1 or the lower quartile, which means 25% of the data set has a value less than or equal to the lower quartile. Quartile 2 or the second quartile, which is known as the median, which means 50% of the data set has a value less than or equal to the median or the quartile 2. The position of the upper quartile, which is Q of 3, means 75% of the data set has a value which is less than or equal to the third quartile. Let's have an example. Before we proceed to the example, let me present the formula in finding the quartile of an ungrouped data. Q of k equals the quantity of k over 4 times the quantity of n plus 1 value. So this means we are looking for the position of that value, where qk or q of k is the quartile, k is the quartile rank, and n is the number of values in the data set. Values could also be known as the observations, the raw data, or the scores. Linear interpolation has few steps. Step 1, arrange the scores, the values or the observations to an array, usually in ascending order. Step 2, locate the position of score in the distribution by using this formula to find the quartile. Step 3, if the result is a decimal number, proceed to interpolation. In other words, linear interpolation could be used if the resulting position is a decimal number. Use this formula in using linear interpolation. That is, score in kth position equals the lower value plus the decimal part times the higher value minus the lower value. Let's proceed to this example. Number 1. Find the lower quartile, Q of 1, second quartile, Q of 2, in the upper quartile, Q of 3, given the scores of 13 students in their mathematics quiz. Then interpret the result. For the solution, step 1, because we're going to apply the linear interpolation, or if you're going to measure the position of a score in a certain distribution, it should be arranged into an array or in ascending order. So, step 1, you have to arrange the data values in ascending order. Then count the number of data values or scores. There are 13. First, let us find the lower quartile, Q of 1. Using the formula for quartile, then substitute the given. K is 1 because we're looking for the lower quartile. And then N is 13. Therefore, the position of the lower quartile is at 3.5 value. Since it's 3.5 value, this means that it is the value of the quartile 1 or the lower quartile is between the third and the fourth value. Going back to the array, counting from the lowest value until we reach the third and the fourth. Therefore, the third and the fourth value is 7 and 10. Applying or using the linear interpolation, the score in the 3.5 position is lower value is 7 plus the decimal part of the position 3.5, that is 0.5. Quantity 10 is the higher value, which is the fourth value, minus the lower value 7. Simplifying, therefore, quartile 1 is 8.5. Okay, locating the quartile 1, which is 8.5, so it is at the middle of 7 and 10. How to interpret this position? There are three, the 25%, which is there are 3 values of the distribution, falls below 8.5. And the remaining 75% of the distribution falls above quartile 1, which is equal to 8.5. You can also say that there are 3 values which is less than 8.5, and there are 10 values which is above 8.5. Let's go find quartile 2. We know already that the n is equal to 13. Again, using the formula to find the quartile and substituting the values, k is 2, n is 13. Therefore, the position of the quartile 2 or the median is the 7th score. Counting from the lowest value from the array, 1, 2, 3, 4, 5, 6, 7. 7th value is 13. Therefore, 13 is the median or the second quartile. Now, how do we interpret the result? Thirteen is quartile 2. Therefore, 50% of the distribution falls below 13, and the remaining 50% falls above 13. You can also say that there are 1, 2, 3, 4, 5, 6 values or data values that is below 13, and 1, 2, 3, 4, 5, 6 values falls above 13. Next, finding quartile 3 or the upper quartile or the third quartile. Again, using the formula to find the quartile and then substitute the values. K is 3 because we're looking for the third quartile. Then simplifying the formula. Therefore, the third quartile or the upper quartile is at 10.5th value. This means that the value is between 10 and 11th. Counting from the lowest value to find the 10th and 11th. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the 10th and 11 is or are 22 and 26 respectively. Applying the linear interpolation, score in the 10.5th position is 22 is the lower value plus the decimal part of the position 10.5, quantity 26, which is the lower value minus the lower value 22. Therefore, quartile 3 or the upper quartile is 24. Interpreting the result, quartile 3 is at the middle of 22 and 26. You can say that 75% of the distribution falls below 24, and the remaining 25% falls above 24. You can also say that there are 10 scores that falls below 24, and there are 3 data scores that falls above 24. Next example. Example number 2. Listed below are the numbers of students in 12 colleges that are qualified in a scholarship program offered by the local government. Find Q of 1, Q of 2, Q of 3 using linear interpolation. Then interpret the result. Okay. Step 1, we have to arrange the data values into an array, specifically into an ascending order. Then count the number of values. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Therefore, n is 12. Let's start finding first quartile or the lower quartile using the formula to find quartile, and then substitute the given. K is 1, n is 12. Therefore, the position of the lower quartile is at 3.25th value. Locating 3.25th for the position of quartile 1. So let's count from the lowest value 14 until you reach third and fourth. 1, 2, 3, 4. So that is 19 and 23. Applying the interpolation, we have the score in 3.25th position is 19, which is the lower value, plus the decimal part of the position 3.25th, and then 23, which is the higher value minus the lower value 19. Therefore, quartile 1 is 20. Now, how do we interpret the result? First, let us locate quartile 1, which is 20. So it's at the middle of 19 and 23. We can say that 25% of the distribution falls below 20, while the remaining 75% falls above 20. Let's find the third quartile. Next is finding the quartile 2, or the second quartile, which is also known as the median. Now in this case, or in finding the median or the quartile 2, just only apply the median rule. Okay? Using the formula in finding the quartile, and then substitute the given, which is n is 12 and k is 2, because we're looking for the median. And then simplifying, therefore the position of the quartile 2, or the median, is at 6.5. Therefore it's between 6th and 7th. Counting from the starting from the lowest value until you reach the 6th and the 7th, therefore it's 23 and 38. Applying the median rule, because there are two values in quartile 2, let's get their average. That is 23 plus 38 divided by 2 is 30.5. Okay, let us interpret the result. The median is at the middle of 23 and 38, and that is 30.5. This means that 50% of the distribution falls below 30.5, and the remaining 50% falls above 30.5. You can also say that 1, 2, 3, 4, 5, 6, there are 6 data values in the distribution that falls below 30.5, and there are also 6 values that falls above 30.5. Let's go find the third quartile, or the upper quartile. Always remember that in finding the measures of position, you have to arrange the data values into an array. Okay. So substituting the given values into the formula of quartile, n is 12 and k is 3, because we're looking for the upper quartile. Therefore, the position of the third quartile is at 9.75. This is between the 9th and the 10th value. Counting from the lowest value until you reach the 9th and 10th value. In this data set, the 9th is 43 and the 10th value is 44. Applying the interpolation, score in the 9.75th value is equal to 43, which is the lower value, plus the decimal part, 0.75, quantity, higher value 44 minus the lower value 43. Therefore, the upper quartile is 43.75. To interpret the result, let us locate quartile 3, which is near 44 because it's 43.75. This means that 75% of the distribution falls below 43.75, or we can say that there are 1, 2, 3, 4, 5, 6, 7, 8, 9 values that belong to the 75% that is below 43.75, and then the remaining 25% falls above 43.75. Okay, so that's it. I hope you've learned something from this. Other measures of position are also available in this channel. Bye!